If you had fun with imaginary numbers, now let's add normal numbers to imaginary numbers, and we're going to call them complex numbers. Don't worry, they're not that complicated. But welcome to 4.5. Let's get started. All right, here we are. We're talking about complex numbers. We just got done with imaginary numbers, and complex numbers are just basically a normal number plus or minus an imaginary number. And that's it. You just treat I essentially like a variable. So if we're going to define it, a complex number is a number written in the form of a plus bi, where b is your imaginary part and a is your real part. So where a is your real part and b is your imaginary part. So they're going to look something like, 6 minus 3i, or -4 minus 7i, or 8 plus 2i. So they can, the coefficients essentially can be positive or negative, whatever, it doesn't matter. So then after that, once we get to that part, we can start adding and subtracting these complex numbers. So it's not as bad as you think if you just think of I as a variable. So if we were to put like an X here, this is a problem that you should be able to do at this point. So it's going to be the same thing. We're just going to combine like terms at this point. So our -11 and our 9, when we combine, we've got -2. And then when we take our 3i and our 2i, we're going to have plus 5i. So then all together, our answer is just -2 plus 5i. That's it. Just treat I like a variable, and then if you see an I squared, just turn it into -1 and you're good to go. So we'll do number 2 again. 4 plus 7, so we're going to have 11. I minus 5i, we're going to have minus 4i. Easy as that. So then we've got some negative signs. Just distribute the negative sign. That's usually what I do. Otherwise, I will forget about it. And then again, combine like terms. So number 3's got a negative sign, but we're just going to distribute that negative sign or else I will forget about it. And then again, we're just going to combine like terms. So 7 minus 2 is 10 7, 6, 5. I knew that. 5 minus 2i minus 6i. It's going to be a -8i. And then if we're to come over here to number 4, okay, so we've got a couple of extra things going on, but again, just treat I like an X, and then we should be okay. So we're just going to combine. Well, first, I'm going to distribute this so that I don't forget about it. And then we're just going to combine like terms. We have a 6i, a regular I, and a -3i. So that's going to be 3, 4. We're going to have 4i. And then we've got a -14 and 5. So -9. And in general, we like to write our answers with our real number, or our real number first, and then our imaginary number second. If you don't do that in your answer, that's okay, but it's a good habit to get into. Okay, so multiplying can be a little bit more interesting just because we can run into some I squareds. But again, treat I like a variable, and just remember I squared, oh, it's not written there. I squared equals -1. If you can remember that, again, just treat I like a variable, and this should be pretty easy. So for number 5, we're going to distribute that 2i in. So then we're going to have 16i minus 6i squared. Remember, I squared is -1. So this is -1 times -6. So now we've got 16i plus 6. And just because I want to be super cool and awesome, I'm going to put my real number first and my imaginary number second. So we keep going to number 6. We're going to distribute this in. So we're going to have a positive 2i plus a negative 10i squared. Again, I squared is negative 1, so that's going to switch the sign of the 10. And then what we have left over, we're going to put my 10 in front plus 2i. So for number 7, we've got a polynomial times polynomial, or two complex numbers multiplied by each other. So we're just going to essentially FOIL them out. And again, I squared equals negative 1, so let's do it. So 7 times 4, we've got 28. 7 times negative I, we've got negative 7i. I times 4 is plus 4i. And then I times negative I is negative I squared. Remember, this is going to just switch our sign here. And this is going to be a 1. I'm just going to write that up there just so I don't forget. We can combine these like terms. We can combine these like terms. And here we go. So we got 28, 29. And then negative 7, negative 3, right? Yeah. Minus 3i. And that's it. So we'll do the same thing over here. We're going to distribute this too. Not distribute. We're going to FOIL these two things together. So then we're going to have negative 10, 2 times negative 5. We're going to have 2 times negative 3. We're going to have negative 4 times 5, negative 5. So it's going to be a positive 20i. And then a negative 4 times a negative 3i. It's going to be a positive 612i squared. So this is going to turn into negative 1. And let's see what else we got. We've got a negative 12 and a negative 10. So we're going to have negative 22 plus, got a 6i and a negative 6i and a 20i. 14i, right? Right. So number 9, you can treat it like a polynomial squared. Again, if you remember that super fancy equation of like the first one squared times 2 times the second one times the second one squared, or plus, minus, whatever, great, you can use that. I don't remember it, so I'm going to have to write it out. So 6 minus 2i times 6 minus 2i. So then I'm just going to FOIL that out. So then we've got 36, right there, minus 12i, negative 2i times 6 minus 12i, and then negative 2i will be plus 4i squared. That turns into a negative. So then this can be combined with that. These two can be combined. And then we've got negative 24i and 32. And there's your answer in pretty colors. So number 10, it's the same concept. Again, treat I like an X, and then we'll just go for it. We're just combining a bunch of stuff at this point. So we're going to FOIL this part out. So we've got 9 plus 3i. We're going to FOIL this part out. 7 times 9. I totally didn't forget that. 63i, and then 7 times 3 is going to be 21. I times I is I squared. We are going to do some good note keeping and make sure this 4 plus 2i, so I distributed that negative sign in. Make sure that makes it down. And then at this point, we just need to combine like terms. So I see a normal number, see a normal number, I see an I, an I, an I, and an I. So 9 minus 4 is... Hang on, I did something wrong. So I think that I did something wrong, so I don't see an I squared there, and I should. So this 7 multiplied by this 3 should be 21i squared, and it looks like I forgot to put my square there, so don't forget about that. So that changes things a little bit. So this is now going to be yellow, whatever. Anyway, so let's see here. We've got now a negative sign and that I. Okay, so then negative 21 minus 4 is negative 25. Plus 9 is negative 16. So then we combine all of our i's. We've got this one and this one, 66i, right? Minus 2, 7, 6, 5, 4. So we've got plus 64i. And there we go. Don't forget this stuff, it's just good note keeping. Just don't lose this part right there. Okay, down here at 11, we have these things called complex conjugates. And they're kind of interesting, and you should kind of remember the word, but I'm not a huge fan of vocabulary. But a complex conjugate, it's more important about what it does. So first, what is it? So if we start with 8 plus I, the complex conjugate is going to be this guy right here. Notice that it's the same numbers, just a different sign in between. So it's the opposite of our original complex number. So these are going to be very useful later on, because watch what happens when we do the math with them. So, okay, we FOIL this out. 8 times 8. So we're going to have 64. 8 times 8. 8 times negative I is going to be negative 8i. I times 8 is a positive 8i, and then I times negative 1 is a negative I squared. So hopefully you notice we've got a negative 8i and a positive 8i. So those are both going to cancel out. Then we have an I squared, which hopefully you remember is just negative 1. And then we have a negative times a negative, so we're going to have a plus 1. So all things said and done, our final answer is 64 plus 1, which is 65. Notice that our answer does not have any i's in it. So these complex conjugates are really useful for getting rid of i's, or turning a complex number into a normal number, if you will. So let's do some more examples and see how they work. Okay, admittedly I skipped 12, but here I am at 13, so whatever, it'll be okay. So we've got 5 times 5, so we're going to have 25. We got 5 times 4i, so we're going to have plus 20i. Negative 4 times 5, negative 20i. And then negative 4 times 4i, which is 8. 16 minus 16i squared. So again, we've got a complex conjugate, but even though we've got a negative sign over here, so the complex conjugate is just going to have a positive sign. So hopefully you see that, hopefully you pick up on that. Okay, so we've got a positive 20 and a negative 20i. We've got an I squared, which remember turns into negative 1, which will just change the sign. So then, all things said and done, what we have left over is 20, 25 plus 16. So we have 41. Okay, so we're going to move right over on to 14. So again, we've got negative 7 times negative 7 is a positive 49. Negative 7 times negative 2i, positive 14i. I'm trying to keep track of my negative signs. 2 times negative 7 minus 14i. And then 2 times negative 2i is negative 4i squared. And again, these cancel out. And then this guy turns into a negative 1, which changes the sign. And then what we have left over is 49 plus 4, which obviously I totally did in my head is 53. Okay, we learned all this complex numbers, imaginary numbers, and all that kind of stuff. Well, let's actually solve some equations with it, right? So down here on 15, we're just going to solve quadratic equations with complex solutions. So here we go. We've got an x plus 2 squared. So we are going to square root both sides. There's a negative sign, but it's okay. We know how to deal with that. So we're going to have x plus 2 equals plus or minus I square root of 81. I just automatically took my I out because I don't feel a need to rewrite everything. 2 is going to come over. We have x equals 2 plus or minus I, and the square root of 81 is 9. So just to be kind of sort of correct, we like to put our 9i first. Again, if you don't do that on your answers, that's fine. It's not a big deal, but I like to at least show and get you guys used to seeing common mathematical nomenclature. Okay, so 16. Again, we're going to square root both sides. We've got x minus 6 equals plus or minus I square root of 32. 32 is divisible by 16. And if you didn't know that off the top of your head, 16 is also divisible by 4. And so 16 is a perfect root. 4s are perfect roots. So you can use your calculator to kind of find all those things. So don't be afraid to use the tools you have. So when we go back to our problem, we're going to move the 6 over. So we've got 6 plus or minus I. So then our 32 is going to change into square root of 16 times 2. So that means we're going to have a 4 on the outside, square root 2. And again, if we're just going to rewrite this correctly, we're going to have 4i root 2. So number 17 and 18 just have a coefficient in front, or in 17's case, there's a negative sign. That's okay. We can multiply both sides by negative 1. Move that negative sign away, because you do want to isolate that square before you take the square root of stuff. So then we've got x plus 4 quantity squared, which is what that's called, negative 75. We'll square root both sides. We got x plus 4 equals plus or minus I square root of 75. 75 divided by 5 is 15, which that is 5 and 3. So we can pull a 25 out. So that means that we're going to have plus or minus I 5 square root of 3. And then we're going to do some good note keeping and bring that down. Now we're going to move our 4 over. x equals negative 4 plus or minus 5I square root of 3. And there you go. Okay, so let's try the same thing for 18. We've got a 2 in front. That's okay. We'll divide both sides by 2. We'll have x minus 1 quantity squared equals negative, whatever 56 divided by 2 is, 28. I knew that. Square root both sides. X minus 1 equals plus or minus I. 28 divided by 4 is 7. So this is like 4 times 7. Square root of 4 is 2. That comes out of the root. We got a 7 left over. So now we're going to take x, move the 1 over, and 1 plus or minus 2I root 7. I don't know what I was thinking. Okay, let's look at number 19. Oh no, there's a fraction. What are we going to do? It's okay, we can deal with fractions in this case. We're going to multiply both sides of the equation by the reciprocal, or got a 2 right there. We're just going to multiply both sides by negative 2. That's going to cancel that out. And we're going to deal with our negative sign as well. So we've got x minus 7 quantity squared equals a negative, whatever, 27 times 2 is 54. Okay, so we're back to our above problems. So we've got x minus 7 equals square root of negative 54, which equals I. Let's see here, what can come out of 54? 9? Hey, look at that. So 54, 9 times 6. 9 is a perfect root, so we're going to have 3 outside of the square root, 6. Don't forget our plus or minus. And then good note keeping, just bring in the left side, haven't touched it yet. Now we're going to move the 7 over. We've got x, 7, plus or minus, and I can switch my 3I around just because I'm a good mathematician. All right, last but not least, number 20. So we've got a more interesting fraction here, but that's okay. All we got to do is multiply by the reciprocal still, both sides. And this is a situation where it's like negative 96 using the calculator times 4 divided by 3 is negative 128 equals x plus 3 quantity squared. So then from there, we're going to square root both sides. So we've got x plus 3 equals plus or minus I, 128, I don't know, 128 divided by 4. Okay, so we got 32 divided by 4 again. And then I can pull another 4 out. 4 times 2, which in this case is 2 and 2. So again, any two numbers that you see that are the same, they can be multiplied together and have a perfect root. So we've got these two, which is 4, these two, which is 16. I'm just going to look at my calculator. 4 times 4 times 2 times 2. So we've got 64. So I can take 128 divided by 64, and that would be times 2. So our new square root is going to be 64 times 2. The square root of 64 is 8, which I didn't even need my calculator for that. You can just take 4 times 2, but whatever. Plus or minus 8I square root of 2. Good note keeping. So then we got x minus 3, 3 went over, plus or minus 8I root 2. And there we have it. We have been using complex numbers. See, I told you they weren't too complicated, right? Awesome. So now you're going to try some practice problems in class. We'll see how it goes. I'll see you there.